Welcome, viewers. I welcome you all for this beautiful course of Internet of Things. Basically, this course is organized in 6 units. In that, first is Introduction to Internet of Things. Second is Embedded Systems for IoT. Third is based on one of the powerful microprocessor called as ARM Cortex M3 microprocessor. Then in section second, uh, communication technologies for IoT are discussed, followed by application layer protocols used in Internet of Things, and then we will see cloud computing, cloud platforms used for IoT at the end of this course. So let's begin with first unit, Introduction to Internet of Things. Textbook recommended for this is Internet of Things by Raj Kamal, and another book is Internet of Things System Architecture Algorithm Methodologies. The contents I am going to describe in this video are Introduction to IoT, different components of IoT system that are embedded system, sensors, communication systems, and the cloud. We will conclude this video with applications of IoT in various domains. So let's begin with the first bit is Introduction to IoT. Internet of Things is a concept which enables communication between interworking devices and applications whereby physical objects or things communicate through internet. The concept of IoT began with things classified as identity communication devices, that is radio frequency identification devices, RFID. It is an example of identity communication devices. Things are tagged to these devices for their identification in future and can be tracked, controlled and monitored using remote computers connected through the internet. The concept of IoT enables, for example, GPS-based tracking, controlling and monitoring of devices, machine-to-machine communication, connected cars, communication between wearable and personal devices and industries. The IoT concept has made smart cities a reality and is also expected to make driving cars functional. Now, let us define Internet of Things. Internet of Things means a network of physical things or objects sending, receiving or communicating information using internet or other communication technologies and network just as a computer, tablet, mobile, and thus enabling the monitoring, coordinating or controlling process across the internet or other data network. You can observe the picture described here. IoT is just a combination of anything, any device, anyone, anybody, any service, any business, any path, any network, any place, anywhere, anytime and any context. So example of this Internet of Thing is through computing an umbrella can be made to function like a living entity. By installing embedded device on umbrella which interact with web-based weather service and the device through the internet, a website regularly publishes the weather report. The umbrella receives those reports each morning, analyzes the data and issues reminder to the owner around his/her office going time. The reminder, that is the message, can be number 1, protect yourself from rain. It's going to rain. Don't forget to carry umbrella. Message number 2, protect yourself from sun. It's going to be hot and sunny. Don't forget to carry the umbrella. So this way the umbrella can behave as a living entity. Another example is street light in the city. Street light in a city can be made to function like living entities through the sensing and computing using embedded system that communicate and interact with a central control and command station through the internet. Assume that each light in a group of 32 street lights consists of sensing, computing, and communication circuit. Each group connected to group controller through Bluetooth or Zigbee. Each controller further connects to the central command and control station through the internet. Now, here is the IoT reference model which is suggested by Cisco. It follows the same concept of OSI reference model. So let's try to understand different functionalities associated with those 7 levels. Level 1 is physical devices and controller, which basically consist of sensors, devices and nodes. Level 2 is connectivity. The responsibility of connectivity is to carry out the communication. Next is level 3 is edge computing. Here data analysis is carried out. Level 4 is data accumulation. This is used to store the data. Next level is data abstraction. The data aggregation and access is allowed with the help of this data abstraction level. Next level is application. Reporting, analysis and control are the tasks performed by application level. And the last, that is level 7, is collaboration and process. This level actually involves people and businesses into the process. Next is IoT conceptual framework. So basically it consists of physical objects plus controller, sensors, actuators plus internet. It forms IoT. The same is implemented in the example of umbrella. Another definition which is applicable for data center and enterprise is gather plus enrich plus stream plus manage plus acquire plus organize is equal to IoT. Note that this is applicable to data center and enterprises. Next framework which is applicable for cloud services, in which gather plus consolidate plus connect plus collect plus assemble plus manage. So this becomes Internet of Things. So Internet of Things gets all those services for data in cloud services. Next is the hardware part of IoT. Basically, it requires a microcontroller. With microcontroller, we have some of the pre-embedded blocks such as processor that process the data. Then we have a RAM. RAM is used to store the data. Next is ROM and firmware. Here we store the programs, instructions, etc. Then we have a timer. So event and overflow can be detected with the help of timer. Next is IO port. So this is required to interface external peripherals with the device. Then we have a serial IO. So with this we can communicate external peripherals in serial communication style. Then we have a PWM. This is required to control the average power supplied by the device. Next is ADC. This will convert analog signals into a digital signal. Actually, one more block has to be added here, that is DAC. So at the output side, we require this DAC to convert digital data into analog data. Next is communication network interface. So here is the IoT architecture, a brief architecture of IoT. So on the left hand side, you can see some of the sensors, actuators, which are able to detect the physical phenomenon such as temperature, humidity and pressure of a remote location. Then next we have IoT gateway or a framework. This consists of embedded system and IoT platform. Then we get the data on a cloud server through internet, and then we can have access to this data from a mobile. So this is just a data acquisition system connected through internet. Next point is different components of an IoT. So major components of IoT devices are physical object with physical object means with embedded system into a hardware. Next is hardware consisting of microcontroller, firmware, sensors, control unit, actuator and communication module. Next is communication module, in which software consisting of system APIs and device interface for communication over internet and communication circuits, and middleware for creating communication stack using 6LoWPAN, CoAP, then IPv4, IPv6, etc. And finally we require the software for action of messages, information and commands which the devices receive and then output to the actuator when enable actions such as glowing LED, robotic hand movement, etc. Now let's begin with the first component of IoT. First component of IoT is an embedded system. An embedded system is a programmed controlling and operating system with a dedicated function within a larger mechanical and electrical system with real-time computing. The embedded system control many devices in common use today. 98% of all microprocessor and microprocessors are manufactured components of embedded system. Modern embedded systems are based on microcontrollers, that is CPU with integrated memory or peripheral interface, but ordinary microprocessors using external chip for memory and peripheral interface circuits are also common. A common standard class of dedicated processor is digital signal processor. There are some more types of processors. In that, first is general purpose processors. In these general purpose processor, you can find microprocessors, microcontrollers, embedded processors, digital signal processors and media processors. This is first general purpose processor. Second one is application specific system processor, that is ASSP, and third one is application specific instruction processor, that is ASIP. The embedded system hardware includes elements like user interface, input-output interfaces, display and memory. Generally, an embedded system comprises power supply, processor, memory, timer, serial communication, ports and system application specific circuits. Next is sensors. Sensors are electronic devices that sense the physical environment. An industrial automation system or robotic system has multiple smart sensors embedded in it. Sensors actuators pairs are used in control system. A smart sensor includes computing and communication circuits. In Internet of street lights, each light has sensors for measuring surrounding light intensity and surrounding traffic proximity. for sensing and transmitting the data after aggregation over a period. Sensors are used for measuring temperature, pressure, humidity, light intensity, traffic proximity, acceleration in an accelerometer, signals in a GPS, proximity sensor, magnetic field in a compass, and magnetic field intensity in a magnetometer. Sensors are of two types. The first type gives analog inputs to the control unit. Examples are thermistor, photoconductor, pressure gauge, Hall sensors. The second type gives digital input to the control unit. For example, touch sensors, proximity sensors, metal sensors, traffic presence sensor, rotary encoder for measuring angles, and linear encoder for measuring linear displacement. Next is communication system. Communication module consists of protocol handlers, message queue, and message cache. A device message queue inserts the message in the queue and deletes the message from the queue in, first out manner. A device message cache stores the received message, and representational state transfer architecture style can be used for HTTP access by get, post, put, and delete method for resource and building the web services. Communication means exchange of information between source and destination reliably. The communication link used in IoT may be wireless or wired. In wired communication, there are two types: serial communication and parallel communication. For long distance communication, serial communication is preferred, and in wireless communication, serial data transmission and reception is done in the form of I2C, that is inter-integrated circuit, or SPI, that is serial peripheral interface. Next point is cloud. Cloud used in IoT. So this cloud is a model of computer data storage in which digital data is stored in logical pools. The physical storage spans multiple servers, sometimes in multiple locations, and the physical environment is typically owned and managed by a hosting company. The cloud storage providers are responsible for keeping the data available and accessible, and the physical environment protected and running. Physical and organizations buy People and organizations buy or lease storage capacity from the providers to store user, organization, or application data. Cloud storage services may be accessed through cloud computing service, a web service application programming interface, or by applications that use APIs such as cloud desktop storage or a cloud storage gateway. History of cloud computing is invented by Joseph Carl in 1960s using ARPANET. In 1983, CompServe offers user a small amount of disk space that could be used to store any files they choose to upload. In 1993, AT&T started personal link services. Files Anywhere in the largest running cloud storage service started in 1999. Amazon introduced AWS S3 in 2006 as a storage supplier. So you can observe the cloud architecture here. This is basically consists of client-side architecture infrastructure in which you may find the IoT platform, sensors, actuators, etc. The data trapped by those sensors are processed by IoT embedded platform, and then it is put on the internet. This internet is actually connected to the cloud server. So cloud at the backend consists of 5 different layers. One is application, then we have a service layer, then we have a storage, security, and management. So application provides you different types of services. Then we have a service layer here what type of data is subscribed by the user is defined, and then we have a storage, actual storage disk partitioned into different types of data. At the security, you have a key management, authorization. These are the responsibilities performed by security level. And the management here, the subscription records are maintained. Next point is applications of IoT in various domains. So basically, I have broadly defined three areas. One is wearable smartwatches, then we have a smart home and the smart cities. So in a wearable smartwatches, you may find nowadays Samsung Galaxy Gear Watch, then we have Apple Watch, then Microsoft Wristband 2. So they comes with different functionalities such as measuring the BP, then heart rate, then they comes with the communication standards like Bluetooth, Zigbee, etc., so that your personal devices can be communicating with those watches. So usually we have more functionalities such as stopwatch, some alarms can be available on those watches, etc. So next is smart home. So in that you may consider a mobile phone, tablet, IPTV. Then we have home security appliances, then light control, home healthcare, fire detection, energy efficiency systems, then solar panel monitoring, temperature monitoring, refrigerator network, then automated meter reading. And third category is smart cities, in which you may have sensors, sensor network, parking spaces, hospitals, streets, vehicle, bank, water supply, roads, bridges, railways, etc. So this is the end of video. So thanks for watching this video. Thank you.